Welcome. Today we are going to discuss on term symbols. Previous class we have discussed about of the microstates and also we have discussed about of terms. So today the topic is term symbols. So I have already discussed that term means that is any short way we are expressing the electronic states of an atoms. The term symbol is the same thing. So we'll just we are explaining that short way of the electronic state of an atoms or ions. So it is also same way we can explain that. And so compared to terms and term symbols, everything is same except that here ls coupling is there, where there is no ls coupling is there. It says if that. So definitions and all things. So let me quickly give it. So definitions. So term symbol means it is the short way of expressing the electronic state of an atom or ions, and it provides the informations uh, let's say the energy, it provides informations of energy, whether it is at high states or whether it is low states, and it gives about of that spin angular momentums and orbit angular momentums. So these things up to this is the same as we discuss about of terms. And term symbol is one addition point is there, that it gives the informations about spin angular momentums. Sorry, spin orbit angular momentum. This is only for term symbols. Means that with adding all the about all the for all about of terms with extra, that is it gives about a spin orbit angular momentums. This is only for this is for term symbols. Okay, so I say that this how you like expressing that representations. This is here that any L, then in multiplicity, then here that J will come. Okay, so previously we have discussed about of that terms. This is term symbols, and we say that for terms only 2s plus 1. Okay, this is for terms where no J will be there. J is, this is a spin orbit angular momentum. We say that L, in previous class we have discussed. What do you mean by L? L is orbit angular momentums, and S is spin angular momentum, that we have already discussed in previous class when we were discussing on terms. Okay, so what we have discussed in the previous class, we have discussed that for terms what we have discussed, that is LL coupling is there, LL coupling and SS coupling. So we say that LL coupling we are doing the two ways. One is if that one orbit is only given, one orbit only, then we used to do that L values, we used to do that summation of L values. And whenever two different orbits, two or more different orbits given, then what we used to do that L value is L1 plus L2 dot L1 minus L2. Okay, and if this is for two different orbits, two different orbit is given, and if three different orbits, then L is equal to L1 plus L2 plus L3 dot L1 minus L2 minus L3 likewise. Okay, so that we have discussed in the previous class. So for SS coupling we used to do that summation of S. Okay, so this we have discussed that this is LL coupling and SS coupling, so that we will discuss in terms. Now for term symbols, whenever we discuss about the term symbols, then here that two things here will comes. One is, so here we discuss about of that LS coupling. Okay, so if atomic number that is less than 42, okay, less than 42, then LS coupling will happen. And if atomic number that is greater than 42, then JJ coupling we will do. Okay, so what are the LS coupling? So we know that how to calculate the S values. Yes, so in terms we have discussed that how to calculate the L value. So L values, we know that if one orbit is there, then we used to do that is summations of L values, and S value is summation of S values. Okay, so if you get L value and S values, then for LS coupling what you do that is LS coupling, that you call that J. Okay, so this is that J, so this J will be L plus S dot L minus S. Okay, so if you take, you will take the examples so that we will understand more. So let's, and this if I discuss about of that this term symbols, so this term symbols, what you say that term symbols for same energy microstates, there will be only one term symbols. Okay, and these term symbols also we call that spectroscopic terms. Spectroscopic term. Okay, so now we'll take the examples so that you will understand more about of it. So let's take the examples. So we know that if any orbits is given, how we will calculate that terms, and term symbols is nearly same, except that in term symbols we will calculate that J values. Okay, so we have done already in the previous class that if that let's say P2 and let's say So any orbit electrons, let's say if it is 2p1 and 3p2 is given, then how do we will calculate that uh, terms we already discussed that. Here we used to do 3, and here 1 electrons, here 1 electrons, and this is 1 0 minus 1, this is 1 0 minus 1, and here that is to calculate that L values. So L values how we will calculate, this is different orbits, so L1 plus L2, and this is L1 plus L2 dot L1 minus L2. Okay, so here that L1 is 1 and 1, that is 2, and this is 1 minus 1, that is going to become 0. Okay, so this will be 2 1 and 0, and S values will be, that we have already discussed in the previous class, that is half plus half dot half minus half. Okay, so this will be 1 and this will be 0. So we have discussed that the terms are, that is 2 1 0 means that is 0 1 2 3, that is S P D and F. So what are that there? S is there, P is there, and D is there. Okay, so if S is equal to 1, then 2S plus 1 will be, that is 2 2 2 plus 1, that will be 3, and if S equal to 0, then 2S plus 1, that will be 0 plus 1, that will be 1. So this will be 3 3 and 3, another will be S P D, that will be 1 1 1. So these are the terms. Okay, now from these terms, if you want to calculate the term symbols, okay, so if S3 is there, let's say S3 is there. Okay, so now we want to calculate that how many terms are there, how many term symbols are there. For that term symbols, I will calculate that. So for that we know that term symbols means that L 2S plus 1 and J value we need. So J we need. Okay, so J is what, that is L plus S, L minus S. Okay, that is simply that L value and S value we have to calculate. So from here, what is the S value? S value is 1, so S is 1. Okay, and now L value how much? For this S, L value is 0. Okay, L value is 0, so you just add it. So 0 plus 1 dot 0 minus 1. Okay, so that will be 1, and this is also 1. Okay, so we get that terms. So term symbols for this S3 will be this and 1. So this is the term symbols. Okay, so similarly, if you want to know that how many term symbols are there for this, so term symbols means what? That is that for the same energy of microstate, or we can say that term symbols that the same words, the term symbols are of all microstates which have same energy. Okay, so that are the term symbols. So what are for S1 3S, these terms, how many same energy microstates are there? Only 1. Okay, that is 3S1. Similarly, if you go for that P3, that is P3. So here if you want to calculate that how many same energy microstates are there, for that I will calculate. So here the 2S plus 1. So S is here 1, because 2S plus 1 is 3, then S value will be, so this is 2S, that is equal to 2, so S is equal to 1, so S is 1, and P, so L value is 0 1 2 3, this is S, this is P, this is D, this is F. So the P value will be, so P is 1, so L value is 1, so J value, that is LS coupling. Okay, that is uh, s plus l dot 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 s minus l. Okay, this, or we can say this the same thing because this mode is there, or we can say l plus s, l minus s, because the negative will be no effect because mode is there. Okay, after negative it comes, then also it become positive. Okay, so this value will be 1 plus 1, 1 plus 1, 1 minus 1, so that will be 2 0. So subtract 1 by 1 from all, so 2 1 and 0. These are the uh, states which have the same energy. So this 3p, this is the terms. The term symbols will be 3p2, 3p1 and 3p0. These are the term symbols. Okay, these are the terms. Okay, now uh, so similarly where you can calculate for d3, we can calculate for s1, p1 and d1 how many term symbols are there. Okay, so now if you may that questions will ask me that why you are calculating these term symbols, why this term symbols is needed it. Okay, so what happened is actually, see that we are everything we are studying in 3D systems. Okay, we are studying in 3D systems. So now whenever you say that like r, let's say this is the sun, so around suns that earth is revolving around it. So when earth is revolves, so you see that when earth is revolving around it, so around suns, when earth is revolving around it, then this earth first it will rotate itself. First it rotate itself, after that it will rotate around the orbit of the suns. So whenever this earth will rotate, there will be some uh, angular momentum is there, and whenever it rotates around the sun, there also another angular momentum is there. So similarly way, okay, if it is suns, similarly way, what happened that when that electrons will rotate, so it will rotate around itself, after that it will rotate around the orbit. So when this rotate around itself, there will create some spin angular momentum. Okay, spin angular momentums, and when it will rotate around these orbits, then again it will create another angular momentum, that is orbit angular momentum, when it will rotate. Okay, so orbit angular momentum, orbit angular momentum. So whenever we couple this, when they will rotate, then there will be a coupling will happen, that is spin and orbit angular momentum. Orbit angular momentum we represent by L, and spin orbit angular momentum we represent by S. So when it will rotate around this orbits, there will be a coupling will happen, so that is called spin angular momentums and orbit angular momentums, there will be coupled. Okay, so that is called spin orbit angular momentum. So that is called spin, means we say S, and this is L. Okay, so that we will code that spin orbit coupling. So that coupling will be represented by J. Okay, so that's why this J is equal to, we say that L plus S, L minus S. Okay, so these things we understand that if the terms is there, how we'll calculate the term symbols, and if orbits is there, how we'll calculate the terms and term symbols. So now we will discuss on the next topic, that is how to calculate that ground states. Okay, how to calculate the ground state? So now so for ground states we have to some conditions we have to some steps we have to follow. First steps is that the maximum value of S is, or you can say that the highest value of S is S, or you can say that spin angular momentums, that is S. The highest value of spin angular momentum, that S is preferred. And second terms, if all have highest value of S, highest value of spin angular momentums S, then look the highest value of orbit angular momentum, that is L. Okay, and if both S and L are same, then what will do that if then two conditions, if less than half filled, then if less than half filled, then L minus S will be the ground states. Okay, if less than half filled. And next questions, if more than half filled, then L plus S will be the ground state. So we calculate about of the terms and term symbols. Now we want to know that which is ground states. So for that case, how we'll do that? We have to follow this three steps. First, you look that S values, the highest S value, then highest L values, and if both S and L are highest, then we will look for this. So preferences will be follows. Okay, past preference is this. This is the first preference, this is second preference, and this will be the third. Okay, so these three steps if you follow, then you will get that ground states. Okay, so for ground states, first we will look S highest values, then if it is same, then go for L value, that is also highest value we will look. Okay, and if both S and L are same, then we will go for L plus S, or we can say L minus S, less than half filled, and L plus S, that is more than half filled. Okay, so this things we will look, so, okay, for the ground state. So let's now take the examples to clear more. So if we have that example, let's say any terms, let's say if you given that let's say d4 is given to you. Then how, then calculate for that ground state. So how will calculate? Then we will do orbitals 1 2 3 4 5 and fill that electrons. So 1 2 3 4. Okay, so now this value, what is this? This is 2, this is 1, this is 0, this is -1, this is -2. Okay, so for it, then we'll calculate that. First we'll calculate the terms. So for terms, how we'll calculate? That is, we will calculate for L value. So this is only uh, one orbit is there, so this will be L1 plus L2 dot 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 L1 minus L2. Okay, this is the L values. Okay, so now this will be, sorry, or if it is one orbit, then L value will be summation of L values. Okay, so that will be 2 into 1 plus 1 into 1 plus 0 into 1 plus 1 into -1. Okay, so you will calculate all this, then that will be 2 plus 1 and that will be plus 0, that will be -1. So that will be this and this, that will be L is equal to 2. Okay, so here L is 2, and for S is how much, how many half? That is also summations of S values. So summation S value is how much? This is 1 2 3 4. So 4 electron is there, and for this, what is the value? Half. So this will be into half, that is going to be 2. Okay, so you know that 0 1 2 3 and 4, this is S, this is P, this is D, this is F, this is G. So this L is equal to 2, so this is D, and S is 2. So if S is 2, then 2S plus 1 will be, that is 2 into 2 plus 1, that is going to 2 2 is 4, 4 1 is 5, that will be 5. Okay, so this is the terms. Now we want to take that, what is the ground states for it. Okay, so what are the term symbols for it? So for term symbols, that is J is L plus S, L plus S, L minus S. Okay, so L is how much? That is 2, and S is also 2. Okay, then that is 2 minus 2, that will be 4, and this will be 0. Okay, so this value will be 4, then subtract 1 by 1 on 3 2 1 and 0. Okay, so these are the term symbols will be there. It means that d5 4, d5 3, d5 2, d5 1 and d5 0. So these all are the term symbols. Okay, so these all are the term symbols. From here we want to calculate that which is the ground states. So how we will do that for ground state? The condition is, first is we look for S value, highest S value. Okay, then we will come for highest L value, and then we will go for half filled or more than half filled. Okay, so from here that first we will look that highest S value. Okay, so everywhere that is 5. So all are, so from one conditions we say that we can distinguish, because everywhere that S is 5 5. Okay, so next we will go for L values. Okay, for L values also we see that everywhere that is 0 1 2 3, this is S, this is P, this is T. So everywhere this L value is 2 2 2 2 2 2, because everywhere it is D D D D. Okay, now next we will go for that more than half filled or less than half filled. Okay, so for if this is less than half filled, then L minus S will look, and more than half filled, then L plus S value will look. Okay, so this is less than half filled, so we will look that L minus S. Okay, so here that this is less than half filled, so you see that 1 2 3 4 5 Okay, so you see that 1 2 3, this is that half filled or fully filled also. Okay, so fully filled and half filled, the same conditions. Okay, these are the half fields or fully fields, and this is less than half fields, and this is more than half fields. Okay, so if less than, this is the one case, this is that one case, and this is one case, and this is one case. Okay, so if that is less than half filled, then we will follow L minus S, and if more than half filled, okay, that will be L plus S. So if half fields or fully fields, then for that case other conditions we will follow. Okay, so here that this is less than half field means L minus S, so L minus S will follow. Okay, so L minus S will be the ground states. So L is, here we see that L is 2 and S is 2, L is 2 and S is also 2. So if you subtract it, then you will get 0. So this value will be the ground state. So this value will be the ground states. Okay, similarly, if that questions will comes, let's say if you have the questions like D6, let's say, okay, so for it 1 2 3 4 5. Okay, so here 1 2 3 4 5 and 6, this is, we see that this is more than half fields. So here is a 2 1 0 minus 1 and minus 2. Okay, so now for this, if you calculate that L values, then L value will be, so summations of L, okay, because this is one orbits. Okay, so summations of L value, so that is 2 into 2 plus 2 in, sorry, that is 1 into 1 plus 1 into 0 plus 1 into minus 1 plus 1 into minus 2. Okay, so this is 2 to the 4 plus this is 1 and this is 0. Okay, and this is minus 1 and this is minus 2. So this will be 4 1 ja 5. So this will cancel and this will be 2. So L value will be, again we get the 2. Okay, similarly S value will be that summations of, so whenever one orbit is there, always do that summations of L value and summations of S value. Okay, summation of S value. So S value is how many, so here that this is half and this is minus half, so they will get cancelled it out, so we will not include it. And this is 1 2 3 4, so 4 into 4 into half. Okay, that will be again 2. Okay, so we see that how many this are there, 1 2 3 4 5, so 5, or we can say that half plus half plus half plus half, 1 2 3 4 plus half. Okay, so 5 1 2 3 4 5 and 1 is minus half, so if we cancel it, then also 1 2 3 4, so 4 into half, that is also 2. Okay, so S value we will get 2. So now we will look for that what are the terms are there for it, then terms will be, that is for all the case L is 2, so that will be D. Okay, and S is 2, if S is 2, then 2S plus 1, that will be 2 to the 4 1, that will be 5, so 5D. Okay, and J value will be L plus S dot 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 L minus S. Okay, so this will be 2 to the 4, that is 4, that will be 0, that will be 4 and 3 and 2, that is 1. Okay, so that will be that D for 3 and, okay, so these are the term symbols. sorry, and 0 is also there. That will be D5 4, D5 3, D5 2, D5 1, D5 0. So these are the term symbols. Okay, from here we want to know that what is the ground state. So first we have to look that S value, highest S value. Okay, past conditions. Next we will look that L, highest L value. Then we will go for that whether this is half filled or more than half filled. So for this case this is more than half filled. Okay, so more than half filled means that we will look for S plus L value. Okay, so S is here 2, S is 2 and L is 2. So S plus L, that will be 2 plus 2, that is going to get 4. So this value will be the ground state. Okay, so we understand that how to calculate that ground states. If we have that term symbols are there, so we will follow these rules. That first we will follow that highest S value, then L value, then that half filled or more than half filled. So S, L, then half filled or more than half filled. Okay, first S, then L. Okay, so that we have to remember it. So this is the way how to calculate that ground states. Let's say if we have that D5 orbitals. Okay, for this case 2 3 4 5. Okay, so let's say 1 2 3 4 and 5. Okay. For this case this is 2 1 0 minus 1 and minus 2. So here also we'll calculate that same way. That is L is how much? That is 2 into 1 plus 1 into 1 plus 1 into 0 plus 1 into minus 1 plus 1 into minus 2. That will be 2 plus 1 plus 0 minus 1 and minus 2. So here we see that this will cancel this and this will cancel with this will cancel with this. So L value is equal to 0. Okay, now we look for S values. S value is 5. So 5 into half, that is going to be 5 upon 2. Okay, so that J is equal to L plus S. Okay, so here we see that L equal to 0 means 0 0 1 2 3. So this is S, this is P, this is D, this is F. So S is 0, so this is will be S. Okay, and that S value is 5 by 2, that is 2S plus 1 will be becomes 2 into 5 upon 2 plus 1, that will get cancelled, that is equal to 6. So 6S. And now that we want to know that what is the this is the terms, and now the term symbols. For term symbols, that is S, L plus S dot dot L minus S. Okay, this is the J value, that is spin and spin orbit coupling. So here L value is 0 and S value is plus half, and this is also again 0 minus 5 upon 2. So here we see that both the cases 5 upon 2, also here minus 5 upon 2, that is mode, so that's again become 5 upon 2. So it means that no gap is there, so this is equal to 5 upon 2. So J value will be 5 upon 2. So J is only one value is come. So here that no need to get that which is ground state, which is etc state, because only one term symbols is there, so this is only the ground states. So whenever that is half filled or fully filled will comes, then there will be only one terms you will get, the term symbols you will get. So here no need to distinguish that which is ground state, which is etc state. If more than 2 term symbols are there, from that we will distinguish that which is ground state. But if it only one is there term symbols, then that is itself is the ground state. So here no need to apply any formulas. Okay, so here direct what will become, that will be the ground states. Okay, so these are that how to calculate that ground states from if orbit electrons is there, and from that how we calculate the ground state. Let's take if we have that some let's say carbon atom is there. From here we want to calculate that ground state. So you know that for carbons it is that 1s2 1s2 2s2 2p2. So this is that valence electrons. Okay, so now 2s2 2s2 2p2. So we will calculate the ground state. So we will look like this. 3. So this is 1 and 2. Okay, so this is 0, this is 1, this is 0, this is -1. So now you want to calculate ground state for the carbon. Then how will calculate it? So whenever this s value is there, then always assume that that is 0. Okay, because this is itself is 0, so 0 into something is always 0. Okay, so now here if you calculate that l value is here, this value is 0. Okay, so this will be that summations of l value. So we will say that different orbits are there, so we should calculate that l as l1 plus l2 dot 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 l1 minus l2. This will come, but the thing is that this s value is become the 0. Okay, so for that only one orbit we will consider, that is this value. So here you will use that summations of l value, because it's treated as only one orbit, because this value is 0. Okay, see that for l values you have to do that l1 plus l2 and l1 minus l2 if that different orbit is there, but this value is 0. Okay, this l value is 0, so only one orbits will comes, only p orbits will come. Similarly for s value, that is summation of half plus summation of half. Okay, so if it is fully filled, then this is again getting the cancelled. If it is half filled, on that case s value we can calculate it, that half plus half and half minus half. Okay, if it is half filled, if it is not fully filled, but here is fully filled, so this is again get cancelled out. So here that l values will, summations of l value will do, that is this is 1 into 1 plus this is 1 into 0, this is plus 0. Okay, so this is 1 and this is again 0, so that will l value will get, that is 1. Okay, and similarly for s values, s value what is that so this is cancel it up, because plus half and minus half, and this is 2, so 2 into half, that is going to 1. So l is 1, then s p d f, this is 0, this is 1, this is 2, this is 3, so s is p is 1. So if l value is 1, then that is p, so p, and s is 1, so 2s plus 1, that is 2 1 are 2 plus 1, that will be 3, so this will be 3. Okay, now we want to calculate that j value, then that is l plus s, l minus s. Okay, so here that l is 1 plus s is also 1, and l minus s, that is 1 minus 1, that is going to become 2 and 0, that is 2 1 and 0. Okay, so this will be 3p2 3p1 and this is 3p0. These are the term symbols. Okay, so from here we want to calculate that which is the ground state. Then how we look? First we will look for this whether that s values, so everywhere s value is same, then we will go for l values, l value also everywhere p. Then if it is all are same, this is same, this is same, then we will go for half filled or more than half filled. Okay, so here we see that this is half filled, this is less than half filled, so less than half filled, then l minus s. Okay, so l is 1 and s is also 1, so this is going to get 0, so this will be the ground state. This is the ground state. Okay, so this way we can calculate that which is the ground state, which is the uh, excited state. So the all other are excited states. Okay, similarly if I go for oxygen, let's take what of oxygen. So for that, what is a 1s2 2s2 2p 4. So here you see that this is that valence electrons, so I will pull the valence electrons. So if electrons is fully filled, that s orbitals, then we can neglect it, so we can take only for p orbitals. If you take also, there will be no any let's say no interpretations will be there. Okay, let's say if I take that s and 2 3, so this is 1 and 2, this is 1 2 3 and 4. Okay, so this is L values. For here is 0, this is 1, this is 0, this is -1. So I want to calculate first L value, so that will be the summations of ML value, because this is value is 0, so I am only going to calculate for this values only. So this is 2 into 1 plus, so if I take it is also, you see that there will no effect. This is 0 into 2 electrons are there, 2 plus here 1 into 2 plus 1 into 0 plus 1 into -1. So this value will be 0 and this value will be 2 and this value will be 0, this value will be -1. Okay, so this value will be 2 minus 1, that will be 1. So L value we will getting that 1. So S value will be that how many electrons are there. So you see that this will be get cancel off. Okay, so this is plus half and minus half cancel, so this is also cancel, plus half minus half, only these two are there. So how many electrons are there? 2 half, this is half plus half, because S value is summations of S. Okay, so this is, you see, if you take all this also, let's say the half, and this is minus half, and this is again half, and this is again minus half, and this is half, this is half. So this cancel, this cancel, only this will remain, that is 1. Okay, similarly way here, that this is cancel, this is cancel, so this will be there, that is half into half, so 2 half, that will go into 1. So L value is 1 and S value is 1, so J is L plus S dot dot L minus S. So this value will be 2 and this value will be 0, that is 2 1 and 0. Okay, so here that what you see here, that L value is 1, then that is P, and S is 1, then 2S plus 1 will be becomes, that is 3, so this is 3. Okay, and J value is 210, so that I will say that 2 and 3P1, another 3P0. So from here that you want to calculate that which is the ground state. So for the ground state, what we will do, first we will look that S value, then we will go for L values. Okay, then we will go for whether this is half filled or whether it is more than half filled. So half filled is L minus S we look, and for half filled L plus S we look. Okay, so here we see that for both the cases this is 3 3, and for both the cases L also PPP. So we look that half filled or more than half filled. So for this oxygen, this is more than half filled. Okay, so more than half filled means that L plus S will be looks. So here L is 1 and S is also 1. So this is going to get the value, that is 2. So this value will be the ground state. Okay. So likewise we will calculate that whether this is half filled or whether it is more than half filled. Let's take if it is nitrogen is given. Nitrogen, this is that 2s2 2p3. Okay, for that we can go do that. Here that so we can fill the electrons, that is 1 2, this is 1 2 and 3. So here this is fully filled, so we'll just neglect it, only we look that P3. Okay, the same thing if you take it also, there is no any problems. So we can take only this one because I have already solved taking on this. So this is 1, this is 0, this is -1. Okay, so L value will be that summations of L value, that is 1 into 1 plus 1 into 0 plus 1 into -1, 1 into -1, that is 1, this is plus 0, this is -1, that is going to get 0. So L value is 0. So whenever it is half filled or fully filled, then L value we will get always 0. Okay, so that is 0, 1, 2, 3, 4. So this is S, C, D, F, and G. So S value will get, and now we will go for that. So how many S is there? So S is 1, 2, 3. So summations of all it, because this is get cancelled out. So 1, 2, 3. So 3, and value is half, that is 3 upon 2. So if S is 3 upon 2, then 2S plus 1 will be 2 into 3 upon 2 plus 1, that is get cancelled it off, then this is 4. So S is 4. Sorry, 2S plus 1 will be 4. Okay, so 2S plus 1 you will get, that is 4. So this is going to get 4. Now we will calculate for L plus S values. So this is, we see that this is a fully half filled. So now we see that L plus S for J, that is L minus S. So L plus S is 0, and S value is, we get how much, 3 upon 2 plus 3 upon 2, then again 0 minus 3 upon 2. This is mod, so this is again we will get 3 upon 2, and this is also 3 upon 2. So S value we will get 3 upon 2. So that is for S 3 upon 2. Only one terms we will get. So whenever this is half filled or fully filled, that is the lowest energy states, because from above principles or early principles also we see that for low energy, for ground state, that has to be low energy, and it is fully filled, and this is half filled, then that is highly stable, and that itself is a ground state. So whenever it is half filled or fully filled, then it always we get that only one terms, and that itself is the ground state. Okay, so this is the ground state here. Here no need to apply the all three conditions of ground states. Okay, so similarly, if you take any coordinations compounds, let's say if we have that Cu H2O 2 plus is there, 2 plus, then from here what do you say, that Cu2 plus. So from here we want to calculate that calculate ground state. I will calculate. So Cu2 plus, and copper is what is it, 4s2 3d7. So Cu2 plus will be 3d7. So from here we can fill that 1 2 3 4 5. Okay, so 7 electrons. So 1 2 3 4 5 6 7 electrons. So this is more than half filled. We see that this, if, let me clear it, that confusion may happen sometime. 1 2 3 4 2 3 4 5. So 1 2 3, this is less than half filled, this is more than half filled, and 2 3 5, this is half filled. Okay, this is more than half filled, this is less than half filled, and this is half filled. Okay, so here that, so here we get, this is that more than half filled. So first we will calculate that L values. So this is 2 1 0 -1 and -2. So L value will be summations of, because this is one orbit, so summations of L values, that is 2 into number of electrons, 2 into 2 plus this is 1 into number of electrons 2 plus this is 1 into this is 0 plus this is -1, and number of electron is 1, and this is -2, and number of electron is 1. So this value will be 2 to the power plus this is 2, and this will be 0, and this value will be -1, and this value will be -2. So this value will be g, let's cancel it out, and power -1, that will go and get 3. So L value is 3. Okay, so now from here you can calculate that S values. So S value I will calculate. So this is summations of S value. So this will be how much? So this will cancel it off because this sign represented plus half and this sign represented minus half. So they will cancel out. These two are cancel out. So these 3 electrons. So unpair electrons only will count. Okay. So 1, 2, 3. So 3 into value is half. So that will going to be 3 upon 2. So if S is 3 upon 2, then 2S plus 1, because for terms we need 2S plus 1 value. Okay. So 2S plus 1 will be, so 2 into 3 upon 2 plus 1. Okay, this will cancel it up. That is given 4. So L is 3. 3 means 0, 1, 2, 3, 4. This is S, this is P, this is D, this is F, this is G. So F is 3. Okay, so F and 2S plus 1, you will get that 4. Okay, now we will calculate that LS value, J coupling, that is spin orbit coupling, that is L plus S. This formula is always J, that is L plus S upon L minus S. Okay, so we see that L is 3 plus S is, how much we get S values? Three upon 2. S is 3 upon up 2. Okay, dot 3 minus 3 upon 2. Okay, so either you can do 3 minus 3 upon 2 minus 3, because mod is there, every will get the same value. Okay, so 3 upon 3 upon 2, this is value becomes 1, and this is 2, then you will calculate to 6 plus 3, that is 9 upon 2. Okay, and this value will be what the values? This is that 336 upon 2 minus 3 upon up 2, that is going to be that 3 upon 2. Okay, so this value will get 3 upon 2. So subtract it. Then if you subtract here, everywhere 9 upon up 2 minus 2 upon up 2, then what will value will get? 7 upon 2. Then again if you calculate, this is the 1, so everywhere we subtract the 1. Again if you get 2 upon 2, then we will get 5 upon up 2. Then again if you subtract 2 upon up 2, 2 upon 2 is 1, so I am subtracting everywhere 1. Okay, that is again going to be 3 upon up 2. So what are the values we will get here? So 9 upon up 2, 7 upon up 2, 5 upon up 2, and 3 upon 2. Okay, so these are the J values. So for F we have, so F for that is 9 upon 2, F for that is 7 upon 2, F for that is 5 upon 2, F for that is 3 upon up 2. These are the term symbols. Okay, so from here we want to calculate that which is the ground state. So first we will look at S values, then L values, highest, here also highest. Then if both the cases is same, then we will go for half filled or fully filled. Sorry, half filled or, sorry, this is less than half filled or more than half filled. Okay, so for all the cases we see that for means S value is same, and F for L value, for all the cases F means L value also same. Then we will go for less than half filled or more than half filled. Okay, so this is, from here we see that this is more than half filled. Okay, this is more than half filled. So if more than half filled, then that is L plus S. So L plus S we will look. So this is L plus S. So L is we have 3 and S is we have that 3 upon 2. Okay. So L plus S, that is 3 plus 3 upon 2, that is equal to 9 upon 2. So this value will be the ground state. This value will be the ground state. Okay. So which is our ground state? This value will be the ground state. Okay. So likewise we can consider that which is ground state and which is excited states. Okay. So now we'll go for that next topic, that is for diatomic molecules. Our next topic is diatomic molecules. So diatomic molecule means what I understand, that is means that the molecules, that is diatoms. Okay. So like you say O2, H2, N2, that type of molecules. Okay. These are called the diatomic molecules. So from here what we see that all these kinds of diatomic molecules. Okay. So from here what we see that before we go into diatomic molecules, that some terms we have to remember, that things are that terms are very important whenever we are calculating that ground state or excited states for that diatomic molecules. So what are the terms? First is that unlike here that we say that this is P, this is S, here we should then S, L, 0, 1, 2, 3, and for here L, value will be here for S, here for P, for D, here for F, but for diatomic molecules this L value will be 0, 1, 2, 3, and for unlike this here it will be that sigma and this type of values. Okay, this type of values, these are the L values. So if that is 0, then you will get, unlike here S, here it will be for normal molecules, that will be S, this will be P, and this will be D, and this will be F. But for diatomic molecules L value will be for this, that is sigma, and this is 1 is for pi, and 2 for this delta, and this is for this psi values. Okay, so this type of values we will get for the diatomic molecules. Okay, so this is the one things we have to remember. So this is very simple, that for 0 this is sigma, and this is 1, this is this pi value, and for 2 this is that deltas, and 3 this is for this value. So it will be very you will easily remember when we do the more examples. Okay. And another is the things that here, that very important things, that is that orbit molecular MOT is very important, that will play a very crucial roles, that is molecular orbitals theory. So that is that very basic things. We know that for hydrogens, so here that two types of molecular orbitals we will get, that is like that hydrogens, helium, lithium, beryllium, boron, carbon, and nitrogen. For all these, and oxygens, nitrogens, and fluorines. Okay, for all these kinds of halogens orbitals. So here what we see that here that symmetric orbitals we will get. What I mean by symmetric orbitals? Orbitals in MOT. Okay, so what is that? In this case, that we see that asymmetric orbitals in MOT, that is, let's say that here one orbit is there. So here that always first will be the pi, and this will be that sigma. Okay, so then here also we will get that pi, because this is the symmetry. Okay, here you will get pi, you will get that sigma. So here that we see that from center this is symmetric. Okay, so symmetric orbitals diagrams will be there if for oxygen, nitrogens and fluorines. Okay, and for the case of these atoms like hydrogens, heliums and lithium, beryllium, boron, carbon, nitrogens, here that's non-symmetric orbitals. Non-symmetric orbitals. Let's say this is there, then you see that okay, so this is that, then here we will get that sigma, because for antibondings always comes one is pi star and again that is sigma star. Okay, and this is unsymmetric, so here what we will see that here we will get not this one. If we will get this one, then this is symmetric, but this is unsymmetric, so here we will get that this one. Okay, that is sigma we will get, then we will go for pi. Okay, so this is unsymmetric from the center. So here we will get the pi, here we will get the sigma, but here if we get the pi, here also we will get the pi. So this is unsymmetric from the center. Okay, symmetric in orbital symmetric orbitals in MOT from center. This is non-symmetric orbits in MOT from center. Okay, so for all this case, this type of orbital diagrams we will draw, and for all oxygen, nitrogen and fluorines, for this case we will draw this type of orbital diagrams. Okay, now so these things we have to remember. This will be very helpful, and always it will come. Okay, and next we will remember that this is the sigma and this is that pi. Okay, so third things we have to remember is that whenever if electrons are in sigma or sigma star, okay, if electrons are here sigma or sigma star, then always L value is 0 and L value is 0 and that is always positive will come. Okay, positive will come. That is how we'll discuss. Okay, and fourth terms you have to remember that see that sigma is always G-rate. Why sigma is G-rate? Let's say that here this is sigma, so from here everywhere we will get that same, so this is always G-rate. Okay, this is because sigma orbitals is this type of spherical, so this is always G-rate from the center. Okay, so if sigma is G-rate, then we will go that sigma star and we will go for pi, then we will go for pi star. So this is G, then U and G. So you remember that G, U, G. Okay, and we will order likewise sigma star, pi star, not like sigma then pi then pi star, sigma star, not order like this. We will order like sigma star, pi star for remembering. I'm saying here. Okay, so G is already sigma is always G because this is spherical, so that is G. After that G, U, G. Okay, G, U, G. Okay, we can remember like this. And other things we remember, that is whenever that electrons are G into G, that is always G, and U into U is always G, and G into U is always U, and U into G always U. Okay, so whenever the same G G, then G, U U, then G, and G U, then U, then U G, that is U. Okay, and another things you have to remember, that is uh, whenever electrons, whenever whenever let's say that p orbitals is there, or that is pi is there, let's say that here we will say that 2s plus 1 if it is 1, and if the 2s plus 1 that is 3, then this 1 then always positive, and this 3 then always negative. Okay, so why I'm saying that, will whenever you peel the electrons, then you will understand that why I'm saying these terms. Okay, let's see, we'll take the examples, then you will understand clear. Okay, let's take about of that carbon dioxide. So carbon dioxide means up to nitrogen, after nitrogen, oxygen and chlorines and oxygens, fluorines, all the cases we will look that is symmetric. For carbon this is unsymmetric, so I will draw. So what are the electrons, that is 2s2, 2p2. So this is fully filled, so we will not take only 2p2, we will like 1 2 3 1 2 3. So this is 1 and 2 for one carbon, this is another carbon 1 and 2. So we will peel the electrons likewise. So here that is first will be that pi, then sigma star, this is pi star, this is sigma star, and this is symmetric because this is unsymmetric C2. So first you will here you get sigma, then you will get that sigma star. Okay, so from centers we see that non-symmetric because this is pi star, this is sigma. Okay, so now we will peel the electrons. So this is pi and this is sigma. Okay, and we know that whenever this is that this is 2px, this is 2py, and this whenever sigma is always 2pz. Okay, so whenever that is sigma bonding is there, then there is 2pz orbitals. Okay, so these values are 1 and -1. You know that sigma z value is 0. Okay, so 2px, 2py and 2pz, whatever that 2pz value will be 0, and this is 1, this is -1, this can be -1, this can be 1, but this value is always 0. Okay, so the sigma orbital is always 2pz and that value will be 0. Okay, so now we want to calculate that what are the terms. Okay, for this if you want to calculate the terms, then what we see here, so first we will calculate that L value, similar like we are calculating for that that same way like the CUSO or like that, we calculate that first term. So what are the term, first we will calculate that L value. So here L value will be, see that where it is where the electrons we are able to fill. So 1 2 3 4. Okay, so I'm going to fill the electrons. So 1 2 3 4. So 1 2 3 and 4. So since it is pi orbitals, okay, if it is going to sigma orbitals, then that is always L equal to 0, and that is always sigma. But now it is going to the pi orbitals. So since if it is going to pi orbitals, so now we will calculate that L value. So L value will be that summation. So that is 1, how many electrons, 2 electrons, plus this is -1, how many electrons, 2 electrons, that is 2 minus 2. Okay, that is going to be 0. So L value is 0. Okay, so if L value is 0 and it is in the pi orbitals, then what will do? So actually this point I like to explain this one. This point is actually when L equal to 0 and it is in pi orbitals. Okay, also another is 7, when L equal to 0 and it is sigma orbitals, then it is always that is sigma, and this is always that positive value will come. So no need to look that whether it is positive or negative. But if it is pi orbitals, on that case we will look whether it is positive or negative. Okay, so this is L, then they will get that value will be this sigma, and now we will look that whether this is positive or negative. So now what you will look that S value will look. Now we will look that S values. Here that S value is, how will you look that summations of full electrons. So one, how much, that is half minus half plus half and minus half. So this cancel, this cancel. So S value is 0. So if S value is 0, then 2S plus 1 will be that 0 upon 2, that is 0 plus 1. So if S value is 1, so if S value is 1, then what, this is always positive. Okay, so this will become positive. Okay, now 2S plus 1, so 2S plus 1 value is 1. So this, and whether it is zeroed or unzeroed, how will you look that this carbon dioxide. Okay, so zeroed and unzeroed, how will you look? So if molecule is symmetric, then zeroed. If molecule is symmetric or COS is present in molecule, then only look for zeroed or unzeroed. Okay, so like here the carbon dioxide case, carbon dioxide C2O2 here, that this C and C, so both the side that is COS is present. So if COS is present, then we will go for zeroed or unzeroed, we will check. And if like NO, okay, here that N and O, here that COS is not present, so here you will not look zeroed or unzeroed, this will be not look. Okay, so not look for zeroed and unzeroed. If COS is present, then only you look for zeroed and unzeroed. Okay, so here that carbon dioxide COS is present, because carbon and carbon, here also carbon, here also carbon. So here COS is present, so we will look for whether it is zeroed or unzeroed. Okay, so we see that that sigma, sigma star, pi and pi star, this is always G, this is U, this is U, and this is G. Okay, so here you see that where this is pi orbitals, that is U. Okay, so for one electron, that is U, and two electrons is there, another electrons, that is also U. So U into U, that is G. Okay, another here also one electron, that is U, another electron, that is U, that is equal G, and G into G is again G. So this is G rate. Okay, so this is G rate. So this is the term symbol. Okay, similarly we will calculate another atoms. Let's say if I take about of hydrogens, hydrogen atoms, same that is, we will say that this is sigma and this is sigma star. Okay, so this is have one electrons, this is one electron, so this is this. Okay, so for this case hydrogen also COS is present, so we will look zeroed and unzeroed. First we will calculate that L value. So L value is this. So this is for sigma, it starts from, but this is actually what 1s2. So this is going to be this electron, and this L value is 0. Okay, so 0 into 2, this is always 0. So L is 0. So if L is 0, then that is always this value will come sigma. After that, what you will look for S value. So S value is summations of these electrons. So this is plus half and minus half, that is again 0. So if S value is 0, then 2S plus 1 value will be 2 into 0 plus 1, that is going to be 1. So S value is 1. Okay, so this is 1. And now we'll look that whether whenever it is sigma orbitals, that points I okay, so whenever it is sigma orbitals, then it is always positive. Okay, that's what I written in these points. When L equal to 0 and when L equal to 0 and it is sigma, then always we will get that positive. Okay, so here this is always positives, and here zeroed or unzeroed, how will you look? So this is that both the cases sigma means G, and these two electrons, so G to G, that is again G. So this is also zeroed. So this is that that is term symbols. Okay, similarly if you go for let's say oxygens, I'm going. Okay, so here also what is the 1s2 2s2 2p4. Okay, so here that if I look, then this have completely filled, so that cancel out. I'm taking only 2p4. So oxygen means after oxygen and fluorines, so that I says this one. So this is only oxygen and fluorine. Okay, sorry, this is only for oxygen and fluorine. So whenever this oxygen is there, then this is symmetric. So there will be always that pi star, and this is sigma star. So this is symmetric. So from here will be symmetric. Then this we need that pi, because this here if you go from here, this is pi, then this is pi, then we will got another H sigma. Okay, so this is the 4 electrons. So 1 2 3 and 4. So 1 2 3 and 4. So fill all the electrons. So 1 2 3 4 5 6. 1 2 3 4 5 6 7 8. Okay, so 8 electrons I have to fill. 1 2 3 4 5 6 7 and 8. 1 2 3 4. Yes, 1 2 3 4 5 6 7 8. So 8 electrons. Okay, so this 8 electrons, now where it is in that pi star. So first we will calculate that L values. Okay, so L values will be that here. So here L values I will calculate it. So these are that here, that is whenever that is sigma, then that is always 0, then this is 1, this is -1, and this is 1 and -1, and this is 0. Okay, so sigma will be always 0 for L value also. So here you see that this is 0 into 2 plus here 2 into 1 plus 2 into -1, and here plus 1 into 1 plus 1 into -1. So here we see that that is 0, this is 2, this is -2, this is +1, and this is -1. So all are cancelled. So L value is 0. So if L value is 0, and if it is in pi star orbital, if sigma orbitals, then it is always plus. Okay, if it is pi star or if it is pi orbitals, then what will see that 2s plus 1 will look. Okay, so now we look that S values. So S value means summations of all electrons. So this will cancel off, this is cancel off, this is cancel off. So these are that, these all are cancel it off. Okay, so this is 1 and this is half and half, only unpaired electrons will count. So 2 and value is 1 upon 2. So that is going to be 1. So S is 1, then 2s plus 1 will be 2 into 1 plus 1. That is going to get value 3. Okay, so whenever L is S, then that is sigma and this is 3. Okay, this is 3, and this is oxygen, so G rate, sorry, that COS is present, so we look for G rate and un-G rate. So here we see that this, so we know that sigma star, phi, and phi star. So this is G rate U U G. So G U U G. Okay. So this is where pi star. So pi star is G. Okay. So if it is G and this is 1, so G, and this is also 1 into G. So that is again going to be G rate. Okay. So this is G rate. And now we look that whether positive or negative. So for positive or negative, what we will look? 2s plus 1. Okay. So if 2s plus 1 is 3, then this is negative. Okay, if 2s plus 1 is 1, that is positive. So this is 3, so negative, so negative will come. So this is the symbols. Okay, so for that, actually you have to remember only these points. First point is that what? First point is that orbital diagrams you have to remember. That is for all all like hydrogens, heliums, lithium, up to nitrogens. Here all that non-symmetric from center, and for oxygen and fluorines symmetric from center. Okay, that orbitals you have to remember. Here that orbitals is that I have already drawn. And second things you have to remember is that sigma star, phi, and phi star. So sigma is always G, then this is U, then this is U, then this will be G. So G U U G. Another things, and G into G is always G, and U into U is always G, and G into U, that will be U, and U into G, that will be U. Okay, these things you have to remember. And third things, that if sigma orbitals is sigma or sigma star orbitals, electrons is present, then always L equal to 0, L is 0, and always positive will come. Okay, and G rate or un-G rate check only if COS is present in the molecules. If COS is absent, G rate and un-G rate is not written. Okay, I simply write without writing G rate or un-G rate. Okay, and another points you have to remember, that is if L equal to 0 and electrons are in pi orbitals, pi or pi star orbitals, then if 2s plus 1 is 3, then always negative, and if 2s plus 1 is 1, then always positive. Okay, that you have to look. And if that is L equal to 0 and electrons in sigma orbitals, then it is always positive. Okay, there we no need to check. That's what the point I written. If electrons, if pi star orbitals electron is present, then always positive. Okay, if that I can write, if electrons are in sigma or sigma star orbitals, then always positive will come. Okay, and L is equal to this. Okay, and if L is not equal to 0, okay, if L is not equal to 0, like L equal to 1 or L equal to 2, that is pi or delta, on that case no terms of positive and negative. Positive and negative will not comes. So this will be absent. Okay. So if L is not equal to 0, if it's 1 or 2 or that values, and then positive negative will not comes. Okay. That are the certain things we have to remember whenever we are calculating for ground state terms for diatomic molecules. So in the next class we will discuss about of that ground states for diatomic molecules. So today up to this, thank you.